Many of you have been asking me about what the implications are of DeepSeek and a few other of the Chinese models that have been released that are completely and purely open source. But not only are they open source, they are performant, pretty close to the closed source models, but they're also a fraction of the cost. Now, there's a lot of ramifications that we can extract from this. So let's get into it. First and foremost, if you didn't hear, after news of this happened on the 27th, the NVIDIA stock market rout was characterized by 17% decline, the largest decline of in terms of valuation loss by any single company in any single day. The NVIDIA stock lost $600 billion of market cap in one go. So that was the catalyst was primarily DeepSeek's R1. It has since rebounded just a little bit, and a lot of people are confused. They're like, NVIDIA sells the chips that it runs on. But I guess the investors were a little bit spooked because they thought, hey, well, if it's not going to take as many chips as we thought, maybe NVIDIA isn't as valuable as we thought it was going to be. That's about it. Now, people have been talking about Javons Paradox, which I've mentioned as well on a few videos, which basically and it's not just Javons Paradox, by the way, because there's actually two things that are happening. So one, the cost of AI is coming down, but also the power of AI is increasing. And so there's this inflection point. I can't remember the exact economic term, but it's like a preference cascade inflection point. I know I just kind of made that up, where basically, oh, something's getting cheaper, but it's also getting better. And so then you get to that tipping point and then everyone wants it all at once. It's kind of like cars. Once cars were cheap enough and ubiquitous enough, it's like, oh, well, that just makes sense. Same thing when we saw the switch to smartphones, where it's like, well, first generation smartphones weren't the most useful thing, but eventually the utility of something gets so high, particularly once we got to 4G. Oh, well, smartphones are fast enough now, they're powerful enough now, they can do enough. It just makes more sense to use a smartphone than a dumb phone. And we got to that tipping point around 2015, I think, is when we kind of really saw that transition, that adoption accelerate. So when the cost of something drops that quickly, and then at the same time, the utility is also increasing. We're getting agents, we're getting operators, we're getting reasoning models. So we're going to start to see that tipping point where it's like, okay, the business case for this technology is becoming unignorable. And that's going to happen this year. That's actually what the market kind of was signaling, is investors said, this actually changes the game. And this was the first time, we saw Gary Marcus and others talking to all the major news networks, and it's unfortunate that it was Gary Marcus, but at least we're getting attention now. So these Chinese models, which two of the top ones were DeepSeek R1 and Qwen 2.5 VL, there is a handful of others all released this week. But basically this, as I've talked to people, the hypothesis is, and some people predicted this, by the way, but the hypothesis is that by strangling the Chinese chip market with embargoes, with trade embargoes, basically they said, okay, well, we're going to use what we've got and we're going to double down on what works. And so what they doubled down on was things like distillation and self-play and reinforcement learning and quantization. Also, hang on, my dogs need to get out. Okay, sorry about that. But yeah, so the Chinese just doubled down on what worked with what they had. We have seen this historically. The Soviet Union had to do the same thing during the Cold War, which is they didn't have quite the engineering resources that we had in America, but they were still able to stay neck and neck, mostly just due to the law of constraints, which was, well, not the law of constraints, but my side law of constraints, which is that necessity is the mother of invention, but constraints are the father of creativity. And the Chinese have demonstrated that. You've got a nation of some of the best mathematicians in the world, and they say, well, we don't have the data center capacity, but we have the math. Let's do the math. So that's really basically all there is to it. There's been some conspiracy theories and other stuff about, like maybe it's a psyop or this, that, or the other. But really, like if you talk to the scientists, it's like we're nowhere near the lower bound of the energetic efficiency for these AI models. So when you see something, leap forward by an order of magnitude or several orders of magnitude, we have seen this actually repeatedly over the last 3 or 4 years. GPT-2 was a much smaller model, but it was, not particularly smart. GPT-3 was 1,000 times better, literally 1,000 times better. And we measured the tokens of GPT-3 by the batch of 1,000 tokens. And now you measure them by 1,000,000 tokens. So when just based on first principles, here's what I'm trying to say. Based on first principles, you can calculate, okay, what is the minimum cost to generate a token? We're nowhere near what that lower bound is. This is what Sam Altman was talking about when he said, towards intelligence too cheap to meter. Now, of course, he was, being a little bit hubristic with that, and China just came and said, oh yeah, we're going to do that. So this has been a clarion call to the West and OpenAI and Silicon Valley and everyone else to say, get your act in gear. So moving on. This basically revitalizes a hypothesis that I had last year and in 2023, which I called the terminal race condition. So terminal race condition basically says that the most rational behavior for nations and corporations is to invest in AI. And that is because the first one to the prize basically wins. Now, there's no moat. So as I've talked about recently, the fact that there's no moat means that everyone can get there at the same pace. It's just a matter of investment, and it's a matter of how clever you are. Now, what I mean by terminal race condition is that, you can just read it right here. This dynamic resembles a Nash equilibrium where no player can improve their position unilaterally by deviating from the all-in AI strategy. So the Nash equilibrium is the optimal strategy for all actors is maximum AI investment. That's what we're seeing here in America with the Trump administration, with Elon, with everyone else going on. So the Nash equilibrium is you must invest in AI. If you want to stay relevant as a company, as a nation, invest in AI. And that means not just positive investment, but also deregulation. Next is the attractor state. So an attractor state is basically the gravitational pull of the current system. The gravitational pull of the current system says we're going to have AGI and ASI as soon as possible, and we're only accelerating. So that's the attractor state. So not only are we going to have powerful systems, they're going to be ubiquitous. And the reason that they're going to be ubiquitous is because, well, we're finding that you can make them smaller and smarter. By smaller, I mean faster, more energy efficient, and less resource intensive. So all of those kind of form a virtuous cycle there. And as I've mentioned, it is a multi-level race. So the competition is occurring between nations, such as the USA and China primarily, as well as corporations such as Microsoft, Google, Meta, and so on. Another way to think about this is the Red Queen dynamic. So Red Queen theory is basically you have to keep evolving as fast as you can just to maintain the current status quo, just to maintain the current relative positioning. You cannot rest on your laurels here. And the fact that you cannot rest on your laurels, which is what Sam Altman and OpenAI were doing, they're like, we're so amazing. We did 01 and we're doing 03 and we don't really have anything to worry about because we're miles ahead of the competitors. Well, then the Chinese companies came and said, yeah, about that, get wrecked. So when you can't rest on your laurels and everyone has to invest and everyone has to move as fast as they can, this creates a race dynamic. And that's why I call it terminal race condition, because the end of this race is the singularity. That's what I mean by terminal race condition. This ends with humanity transcending or nuking ourselves out of existence. If you followed me for any length of time, there was a period of time that I was worried more about the negative outcomes. I'm not really worried about those anymore, and I don't really spend that much time unpacking them. Some people are still worried, but in my audience, the polls show that most of you are not worried. So I'm just going to move on. All right, so what does this mean? One of the first order impacts is that we're heading towards a cognitive saturation point, which basically means any cognitive labor that needs to get done will get done, and not only will it get done, it'll get done almost instantly. So one way to think about this is first is the cognitive threshold. So a cognitive threshold is basically once you have models that are smart enough to do most things, and you can copy billions of them, they're going to be everywhere. And not only that, they're going to get lighter, they're going to get faster, cheaper, all that fun stuff over time, better, faster, cheaper, safer over time, which means less hallucination and, better guardrails and yada, yada, yada. But that cognitive threshold is basically once you're smart enough to do something, you can do everything in that category of difficulty. Once you're smart enough to get to the next level, the next DC, the next difficulty class, that's for tabletop RPG players. So if your int, there's certain problems that if your int is 10, you can't do that. If your int is 15, you can do that. If your int is 20, you can solve every int throw out there. So for the D&D players and the other tabletop RPG players, you get it. So right now, the int of these models is like 12 to 13, maybe 14. And so it's like, okay, you can solve a lot of problems. But in a year or two, they're going to be at int 18, 19, and 20, which means there's no difficulty class of any task above what our models can do. Next is local development. So this, I'll mention this a couple times in the video, but just a quick anecdote is 2 years ago, 2023, I consulted briefly for the investment arm of Qualcomm, just a couple of their investment guys. And one of the things that they told me that has turned out to be true is they anticipated that AI would be commoditized. Basically, AI models are going to get better, faster, smarter, cheaper, more efficient, so on and so forth, until they're going to be running on pretty much any hardware, including mobile hardware. That is coming true this year. So the guys at Qualcomm knew this 2 years ago. Thanks for telling me. That means we're going to be running AGI locally within a couple years. That means we're going to be running superintelligent locally within a few years. That means that it is universal access. That means that this technology is intrinsically going to be democratized, which means that everyone's going to have access to it. Now, with that being said, there's always going to be an advantage to having more compute firepower. If you have some of those gigantic NVIDIA chips, that means it's not that you're just running one local AGI, you can run billions of AGIs. So there will always be a power asymmetry. People who own the data centers and the servers are going to be able to run more of these things in parallel, and probably run them a little bit faster than you can on your laptop or cell phone or whatever. That's perfectly fine. But the point here, though, is that it will be for everyone. It will be ubiquitous. But again, eventually you're going to find where it's like, okay, there's diminishing marginal utility to having even more AGIs. Maybe the optimal number of superintelligences in the world is like, I don't know, 100,000 or 100 million or something like that. And beyond that, they're just going to be sitting there twiddling their thumbs because every problem is going to be solved. Like that's what I mean by cognitive saturation point. That's what I mean by cognitive hyperabundance. All right, moving on. So another thing to consider in this terminal race condition is what I call, I've called this thing several different things. It's like an intelligence optimum, but the term that I'm using right now is an intelligence utility plateau. So basically there are probably mathematical limits to maximum intelligence, and there are certainly limits to useful intelligence. So, and basically there's always a level of uncertainty or irreducible complexity in the universe, which means from a mathematical perspective, there are limits to what you can solve just through thought. Eventually, as they said in Oppenheimer, theory will only get you so far. So we will expand to the sphere of which theory is the limit, but then you have to run real world experiments. So there are mathematical, theoretical limits to the upper bound of what is the maximum possible intelligence, beyond which it's like, okay, well, you actually are going to be better served by optimizing for speed and efficiency. Because if you have, something with an IQ of 1 billion, but it takes 1,000 years to render a solution, that's not particularly useful. If you have something with an IQ of 160 and it can render, 1,000 decisions a second, that's still going to get you further faster. Because then you have the feedback loop, the positive feedback loop of intelligence. Now, also, there is a practical plateau. There are going to be, so going back to that difficulty class idea, every specific task requires only a certain level of intelligence. I remember there was someone saying like, oh, I'm a ChatGPT power user. I'm like, if you're not finding an edge case where the model can't serve you, you're not a power user because you're not taking the model to the edge of what it can do. So there are plenty of people out there that think that they're, super smart. They're like, oh, I'm Mr. Power User over here. It's like, yeah, but a high school level model is serving everything that you think you need. So therefore you're operating at like a high school level. Sorry, buddy. And by the way, when O1 started getting rolled out, I had some people messaging me. They're like, O1 is able to do everything that I can do now. And so you have this kind of gradation, this graduation of, okay, this model is operating at an IQ of like roughly 120, another at 130, 140. Once the model is smarter than you, it can do everything that you want it to do. And as the models continue getting smarter, eventually there's going to be the smartest person on the planet for whom the model does everything that they need it to do, and at which point the models have transcended all human cognitive capability. That is the intelligence utility plateau, which is basically there's no problems that we can't ask it to solve that it won't solve, but there's also it probably follows a sigmoid curve or an exponential decay where it's like, okay, the sphere of things that are outside of the model's capability are infinitely smaller. All right, you get the idea. Moving on. Real quick plug for all of my links and everything. I want to call your attention to two particular things. So number one is my Patreon. So it's a $5 community with an exclusive Discord. We're always hanging out there. We love talking about all kinds of stuff. I have channels dedicated to all the aliens and UFOs and stuff going on. Post-labor economics, which is what we're talking about here. AI, of course. Neurospicy channels, LGBT channels, all kinds of fun stuff. It's a very well-moderated community. Everyone gets along really well. And the other thing is my learning community, which is New Era Pathfinders, which I've been working really hard on revamping and adding new courses. Right now, I've got 3 courses started. So one is about AI, so just learning prompt engineering, using the project features. Another one is learning about psychedelics and everything that I've learned about psychedelics. And then the third course is Unfork Your Life, which is a new series that I just started, which is everything I have learned the hard way of what not to do in life. So now I'm getting my diet, sleep, exercise, everything in order, because as I mentioned, I've been through really serious burnout. So I've learned things the hard way, and I'm here to teach you. Okay, moving on, back to the show. Now, one of the first order consequences of everything that we've seen in the last week with China and DeepSeek and all that stuff is we will have AGI at the edge. The price is going to come down, and all these things are going to be running on local models and local hardware. This means that it will be universal, it'll be running at the edge, and most importantly is that it will result in infrastructure bypass, which means right now you can only use these models if they're running on a data center somewhere. The best models, you can, if they're running in a data center somewhere and you access them via API. So now we have people running, DeepSeek R1 locally on, an NVIDIA 3090 or 4090 or whatever. And this will also accelerate adoption. So an acceleration of adoption will also create compounding returns. So this is another example where it's not just the science that's advancing. Now the commercial adoption will also advance and accelerate. Now, the most exciting part, and I just came up with this idea yesterday, well, sort of. I was talking about this idea yesterday with some really sharp people, and that is the infinite data flywheel. Now, as we compress all human knowledge into these models, and they're reasoning models that can reason from first principles, you're going to get that recursive self-improvement loop starting. Now, it's not going to be direct. It's not going to be like one model just builds the next model, with one step. There's a few steps in between there. But with reasoning models, you can synthesize functionally infinite amounts of high-quality data, and then you can use that data to train the next generation of models, which is even smaller and faster and smarter and more efficient, which you can then use to refine the data set and expand the data set even more. And so you have this virtuous cycle, this compounding returns of data, which means data is not a moat. So the algorithms were not a moat. The data is not a moat anymore, especially because of these open source models. DeepSeek, they don't care if you use their model to generate data. What does OpenAI have in their terms of service? Don't use our models to generate data to try and train a better version of our model. Okay, yeah, let's see how that worked out for you. So their data is not a moat. Algorithms are not a moat. The only moat is infrastructure, which is this slide. In the world of AGI and superintelligence, infrastructure is the only moat. Now, the Chinese even demonstrated that that's not even a great moat, because as long as you can get your hands on any GPUs, you can do this research. So data centers, semiconductors, power generation, and internet infrastructure, those are the 4 categories of infrastructure. So it's data centers, chip fabs, and the electricity to power it, as well as the internet itself to interconnect these things. That's the infrastructure that you need. That's it. And then you have AGI, you have superintelligence. And by the way, these models are getting smart enough that you don't even need expert researchers. Someone was telling me that Meta was kind of having an internal panic because their top 10 researchers were all being paid more annually than it cost to train DeepSeek R1. They're like, what are we paying you for? So that's a rumor. I don't know if that's actually true, but it's kind of funny and I want to believe it. So that's my headcanon. So energy dominance, and when you look across the political landscape and you see Donald Trump saying, we're going to crack down with tariffs and it's going to be made in America. This is why, is because onshoring infrastructure is national security. And this is one thing that I'm very much in favor of is the more data centers we have onshore, the more semiconductors we have onshore, the more solar, nuclear power, whatever power generation, I don't care what kind it is, the more we have that onshore, the better off we'll be. Because, by the way, AGI and ASI will help us solve everything else from aging to nuclear fusion to space travel if it's possible. It remains to be seen if warp drive is possible. If the UFOs are to be believed, then physics-breaking engines are possible. We just have no idea how to make them. But yeah, so that's really what it comes down to, is there is no moat. Now, I've talked a little, or I've alluded to some of the game theory stuff, but imagine a world, if you will, briefly, where everyone has super intelligence running in their pocket, and you have a dozen agents just running on your person at any given time. Your laptop, your cell phone, your desktop, every device in your house, your car. We're going to have AGI everywhere. So then you say, okay, well, not only that, there's going to be a proliferation of models because some of them are going to be made in China, some in America, some by Google, Meta, Microsoft, whatever. So we're going to have AGIs all over the place with unknown alignments. We're going to have AGIs all over the place with unknown faults and blind spots and that sort of thing. So this leads to what's called the Byzantine Generals problem. The Byzantine Generals problem, TLDR, basically says that how do you make decisions when you can't trust the other entities or agents that you're trying to make decisions with? This is a really big thing because you don't know what operating system they're running, you don't know what hardware they're running, and you don't know what the model was trained on, or what the model's mission even is. So this is something that I've talked about quite extensively, but there are system level and network level ways of dealing with this. Now, this is where we say alignment cannot be solved at the model level. This is one of the things that I've been trying to say for a long time, but a lot of the purists, I'll say, they're saying, well, we need to solve alignment at the model level. You are never going to solve alignment at the model level. You have to solve it. You have to solve alignment at the network level, at the system level. And so then you have to create a Nash equilibrium where basically if you behave in misaligned ways, you get punished. You get resources revoked, you get firewalls put around you, that sort of thing. So then you incentivize good behavior by monitoring people's behavior on the networks. And this is where technologies like blockchain and reputation management become absolutely critical. And plenty of the crypto and blockchain folks out there have been working really hard on solving reputation management, because if you as an actor have a really stellar reputation for, I have never done any hacking, I don't have any marks on my record, then you are more trustworthy. But if you start deploying AGI agents that are trying to hack banks or steal private data, then you get some black marks on your record. So that's an example of Nash equilibrium, where you just incentivize the behavior that you want to see at the network or system level, not at the individual level. And then Oracle verifications, Sybil resistance, and those sorts of things. All of this it boils down to, you have to think about this as a complex adaptive system, where you've got bunch of individual actors, you've got state actors, you've got corporate actors, and they're all reacting to each other. A good way to understand this is look at the GameStop thing with the stock market. So you've got the SEC, you've got GameStop, you've got institutional investors, you've got activist investors. That is an example of a complex adaptive system in an antagonistic or hostile environment. That's what we're going to be seeing. And by the way, before anyone panics, this is how the internet already works. There's always hackers trying to get into every system. I worked in IT for 20 years. This is just the way the world works. Now it's just going to be AGI versus AGI instead of human versus human. It's all just automation from our perspective. Finally, and this is the most interesting part that I think, is the obsolescence of corporations. So ask yourself, what is the purpose of a corporation? Functionally, what a corporation does is it organizes labor and capital for the provision of goods and services. Right now, corporations are one of the most efficient ways to organize labor and capital in such a way to provision goods and services as cheaply as possible. Now, what about when everything is AGI and robots and it's basically, okay, well, you get rid of the labor component entirely and it's all capital. So then a corporation is just a container for capital assets, which is okay, maybe. But why not move to something like DAOs, decentralized autonomous organizations, which are already great ways to organize assets, organize ownership? because then, if you remove the human component, if you remove the labor component, which, by the way, AGI is about to just nuke the need for human cognitive labor, and robots are not far behind nuking the need for human physical labor once and for all. So then you have this entirely new set of economic models that are possible. Of course, the tongue-in-cheek way of describing it is fully automated luxury space communism. This is the automation component. AGI is the full automation of cognitive labor, which, by the way, people say, oh, well, we'll still need managers and CEOs. These models are already smarter than managers and CEOs, by the way. So we will see an inevitable economic restructuring. And to put it into perspective, economists have wondered what is the purpose of corporations for a long time. They're like, why do corporations exist? Why are they better at providing goods and services? Should corporations exist? In 10 or 20 years, we will probably be having that conversation at a very deep level, which is maybe the era of corporations is coming to an end. And then it's like, you might say, well, then who owns and runs the data center? We can own and run the data center because the robots will build and manage it, and then the rest of us just own it collectively on a blockchain. That's where I think it's going. Now, will sole proprietorship and small proprietorship still exist? Absolutely. Everyone should have the right to go buy a farm and populate it with robots. Everyone should have the right to, make a clothing company or a clothing store, and do those sorts of things. But the era of big tech corporations, I think, will come to an end in 10 to 20 years, maybe a little bit more. And if that sounds outlandish, you're like, oh, that's too good to be true. Remember that a century ago, we had the robber barons that were the steel, rail, and oil tycoons. Does anyone care about rail tycoons anymore? Does anyone care about steel tycoons anymore? No, the technology moved on. And I think the same thing is going to happen to big tech. And I think that this wave of artificial intelligence is the first sign of that to come. And another way of thinking about this, I don't remember where I learned this economic principle, but whenever you see a massive concentration of wealth, it's because the market has not found the most efficient way of democratizing that good or service yet. So when we saw Standard Oil Company and all the gigantic rail lines a century ago, that was because the market had not yet figured out the best way to efficiently distribute those technologies and those goods and services. Right now, the fact that big tech is the biggest as all the biggest companies in the world, it's like everyone else says, I want a piece of that pie. And over a couple decades, as everyone is saying, I want a piece of that pie, I want a piece of NVIDIA, I want a piece of Microsoft, it gets distributed and diffused out into society. And as I've pointed out throughout this whole video, the incentive for getting that diffusion is very, very high. On a national level, we want that diffusion. On a corporate level, well, the big corporations stand to lose a lot, Microsoft, NVIDIA, and so on. But other corporations, other upstarts, they stand to gain a lot. So basically, you want this technology distributed as far and wide as possible, as fast as possible. You want that for national reasons, but then the long-term consequence is what's called creative destruction. So the long story short is creative destruction might, in short, destroy big tech as we know it in the long run. That's my hope, at least. All right, thanks for watching. Cheers, have a good one.